Hi guys, we are looking at Mathematics 1, okay, first year N scheme for Tamilnadu State Diploma students. Okay, this is Unit 1 Algebra, Matrices and Determinants. So let's see the introduction part first. Matrix and its applications are very important part of mathematics. Also, it is one of the most powerful tools in mathematics. Matrix notation and operations are used in electronic spreadsheet programs on personal computer, which are used in like business, budgeting, sales projection, cost estimation, analyzing the result of experiment. Also, many physical operations such as magnification, rotation, and reflection through a plane can be represented mathematically by matrices. Also, matrices are used in cryptography. Okay, what is cryptography? Right, the art of writing or solving codes. Okay, that is cryptography. Matrix is represented by a rectangular array of numbers or functions arranged in rows and columns put within brackets. Okay, the numbers or functions which are entries are called elements of the matrix. For example, if this is a matrix, every single digit, okay, every digit is a element of the matrix. Okay, this is an example of matrix. Raju has 10 notebooks and 15 pens. Mani has five notebooks and 2 pens. Mother has 9 notebooks and 5 pens. So the above information can be represented in a condensed form in this matrix as follows. Note of books as columns, first column, pens as second column, and the persons as rows. Raju, Mani, Malar. Raju has 10 notebooks, 15 pens. Mani, 5 notebooks, 2 pens. Malar, 9 notebooks and 2 pens. Okay, that's how we got the matrix. Consider the linear equation with three unknowns a, b, c. A plus b plus c equal to 3. 2a minus b plus c equal to 2. 3a plus 2b minus 2c equal to 3. These are called simultaneous linear equations. Okay, with three unknowns in this case. These can be written in form of a matrix. Okay, by writing the coefficients only. Okay, let's say if you write those coefficients of a and b and c, that is that matrix is a matrix. Okay, 1 1 1, 2 minus 1 1, 3 2 minus 2. Okay, the horizontal lines of elements are called row. This is row, and column is vertical line of elements is called column. Okay, this one has three rows, three columns. Okay, when a matrix has same number of rows and same number of columns, it is called a square matrix. Okay, order of matrix. If a matrix has m rows and n column, then the order of the matrix is m by n. Okay, read as m by n, not m cross n. Okay, so this is having three rows and two columns, 3 by 2. Order is 3 by 2. Find the order of the following matrix. So this is 3 by 3 and this is 2 by 2. These two are square matrices of different order, and this is one row and three columns, 1 by 3, and this is 1 2 3, three rows, one column, 3 by 1. Row matrix, a matrix is said to be row matrix if it has only one row and any number of columns. Okay, simply one row, columns can be any number. In this case 1 by 3, three columns and one row. Okay, column matrix said to be column matrix if it has only one column and any number of rows. This matrix is 3 by 1, 3 rows and 1 column. Null matrix is zero matrix. If the all elements of the matrix are 0, then it is called null or zero matrix. It is denoted by O. Okay, this is zero matrix of order 2 by 2. Square matrix, a matrix, the number of rows and the number of column of matrix are equal, then it is called square matrix. In this case it is 3 by 3. Okay, triangular matrix, upper triangular matrix. In a square matrix, if all the elements below the leading diagonal, this is called leading diagonal. Okay, one, the first row, first column entry, second row, second column entry, third row, third column entry. Okay, this is diagonal elements. Okay, this is called lead diagonal. If the of all the elements under the under the lead diagonal are 0, then it's called upper triangular matrix. Only non-zeros entries are in the upper triangular. Okay, lower triangular they are 0, that's why it is called upper triangular matrix. Okay, this forms a triangle, right? Law of triangle matrix. In a square matrix, if all the elements above the lead diagonal are zeros, then it is called law of triangular matrix. A transpose, how to get transpose? If you change the elements of the column to the row to the column, they are called transpose. Okay. For example, in this a matrix, 203 is first row. Make it first column. Okay. 156 second column. 2 minus 19 third column. Then you got the transpose. Okay. If you check the column as well, this column becomes the row in the transpose matrix. Okay, both are interchanged. The columns and the rows are interchanged simply. If the matrix A is of the order m by n, then the order for A transpose is n by m. That is straightforward. A transpose, old transpose. If you again do the transpose, you will get the same matrix. You can check it. Okay, if you transpose this A transpose, you will get the same matrix. So A transpose old transpose is equal to A. Symmetric matrix, a matrix is called a symmetric matrix if A is equal to A transpose. Okay. So except the main diagonal, these elements are equal. Here H, here H, here G, here G. Okay. Similarly, here the element should be same. Then the A will becomes A transpose. Then it is called symmetric. What is skew symmetric matrix? A square matrix A is called skew symmetric if A equal to minus A transpose. Okay, right. Diagonal matrix. In a square matrix, if all the elements other than the main diagonal are 0, then it is called diagonal matrix. Okay. Scalar matrix, a diagonal matrix in which all the elements are equal, then it is called scalar matrix. Unit matrix, a square matrix in which all the elements of the leading diagonal are 1 and other elements are 0, then it is called unit matrix and it is denoted by I. I3 is 3 by 3 unit matrix. Okay, or unit matrix of the order 3. I2 is the unit matrix of order 2. Operations on matrices: addition and subtraction of matrices, multiplication of matrix by scalar, multiplication of two matrices. Addition is straightforward, pretty straightforward. The corresponding elements must be added. Okay, this is A, this is B. When you add A and B, 1 plus 1 in the first row, first column, in the first row, second, first row, second column, first element will be 2 plus 3. The first row, third column element 7 plus 1, like that. Corresponding elements are added. That is pretty straightforward. Negation also the same. The corresponding elements of those matrices are subtracted. Multiplication of matrix by scalar. We can multiply the matrix by any non-zero scalar k. To multiply the matrix by a scalar k, multiply all the elements with the same scalar. Okay. 2a means 8, 6, 4, like that. Okay. You are multiplying every element with the same number. Okay. That is pretty simple. Yeah, you can do this. 4a minus 2b, 4 into a this, 2 into b is this, 4a minus 2b is this. Okay, multiplication of matrices. This is little bit involved. Okay, what is the secret? The row must be multiplied with the column. Okay, you want AB the first row, first column element, A1 P1 plus B1 P2. Okay, second element A1 Q1 plus B1 Q2. Second row, that means first row, here the first row must be multiplied with second column. Now you want second row, first column element, then second row must be multiplied with, second row of A must be multiplied with first column of B. So A2 P1 plus B2 P2. Similarly, if you want the second row, second column element for AB, this can be obtained by multiplying second row with the second column, second row of A with the second column of B. That is A2 Q1 plus B2 Q2. Okay, not very difficult. Similarly, you can perform BC here: P1 X1 plus Q1 X2, P1 Y1 plus P2, sorry, Q1 Y2. This one P2 X1 plus Q2 X2, P2 Y1 plus Q2 Y2. Okay. Now you can find AB simply 1 3 minus 5. Okay, this is 4, that is the other element is 0. 3 plus 10, 4 plus 0. Okay, like that. Verify AB equal to BA. First you perform AB and also perform BA. Okay, if they are equal, then you can state AB equal to BA, but they are not equal here, right? So AB not equal to BA. So A into B plus C equal to AB plus AC. Fine. A is this, B is this, C is this. Verify AB into C equal to A into BC. That you can do, okay, as an exercise. Not very difficult. This also you can verify, okay, by doing individually, LHS and RHS side. Properties of matrices. So commutative property in matrix addition. For any matrix A and B of the same order, matrix addition is commutative. A plus B equal to B plus C. Matrix multiplication is not commutative in general, that is AB not equal to BA. Associative property in matrix addition, that is valid. A plus B plus C equal to A plus B plus C. Okay, for any matrices of the same order. Associative property in matrix multiplication, A into B C equal to AB into C. Okay. Identity property of matrix addition. For any matrix A, there exists a matrix 0 O of the same order such that A plus O equal to O plus A equal to A. O is a 0 matrix. Identity property in matrix multiplication. For any matrix A, there exists identity matrix A such that A equal to IA equal to A, where I is unit matrix. Inverse property for any matrix A, minus A is the additive inverse of A such that A plus minus A equal to O. Okay, or minus A plus A equal to O. Distributive property or addition, matrix multiplication is left distributive over addition, that is A into B plus C equal to AB plus AC. Matrix multiplication is right distributive over addition, that is A plus B into C equal to AC plus BC. Scalar multiplication is distributive over addition, that is AA plus BA, where A and B are scalars. AA plus AB, where A is scalar. Okay. These are some worked out examples given. Verify that A plus B equal to B plus A. Pretty straightforward. This is also pretty straightforward. Yeah, you can go through it. Okay. Verify that A plus B plus C equal to A plus B plus C. This is also very simple. Okay. You can do that. Coming to the exercise problem, verify that A into B plus C equal to AB plus AC for the following matrices A, B, and C. Is that little involved? No. No? Yes. Anyway, the orders are not going to say. If the orders are same for A and B and C, pretty easy. Okay. For multiplication, you always see the number of see when you are multiplying A and B. First, you need to check the number of columns of A and the number of rows of B must be equal. Then only multiplication is possible for matrices. Okay. The number, for example, number of columns for A here it is 3. Number of rows for B here it is 3. So multiplication is possible. Okay. The resulting multiplied matrix AB will be having number of rows such as A and number of columns such as B. That is, this is 2 cross 3, 2 by 3, and this is 3 by 2. So AB will be having 2 by 2. Okay, you got the point. Okay, let's do some one example. What's the big deal in it? Right. Mm-hmm. A equal to, what is here? Right. 2 0 minus 3 1 4 5. 2 0 minus 3 1 4 5. 2 0 minus 3 1 4 5. That is here. Okay, this is bracket, here it is Fine. Right. That is A. What about B? Why to take one more? Okay, what about V? V equal to 3 1 minus 1 0 4 2. 3 1 minus 1 0 4 2. Okay. 3 1. Next, minus 1 0. Minus 1 0. Minus 1 0. Next, 4 2. Right. Okay. This is 3. What about C? C also having 3 rows and 2 columns, 3 by 2 matrix. So you can simply take the help of B. Okay. What about this? This is C. C elements 4 7 2 1 4 7 2 1. Okay. 4 7 2 1. The third one is 1 minus 1. Okay. 1 minus 1 1 minus 1. Fine. Fine. So now we wrote A, B, C. Now we have to do first LHS side, A into B plus C. Then we have to proceed like this. LHS, left hand side. Okay. A into B plus C you want. First you do B plus C. Okay. What is B plus C? Adding B and C. That is pretty straightforward, right? Then we will do it like this. Okay. Right. Equal to equal to. Then they came in the same order, right? Right. 3 plus 4 7. Okay. 7 plus 1 8. Minus 1 plus 2. This is plus 1. This becomes plus 1 now. 1 plus 0 1. Next is 4 plus 1 5. Corresponding elements only we are adding. 2 minus 1 1. This is B plus C. Okay. We are proceeding with LHS side. That is what I mean to say here. So A into B plus C. That is what we want now. Yeah, A into B plus C. This is A. This is B plus C. Now what I have to write here? A into B plus C. How it is going to be this thing multiplied with this thing. So we will write them together. Yes, A has to come here. Fine. This is A and this is B plus C. Right. This is 2 by 3. This is 3 by 2. As I told earlier, what you will get ultimately 2 by 2 matrix. How it is going to be? The first row with the first column. 2 7s 14, 0 1s 0, minus 15. 14 minus 15. I am directly writing the answer. 14 minus 15 is minus 1. Okay. That is the first element, first row, first column element. Next, first row, second column element. This first row with second column. 16 minus 3. That is 13. 13. Okay. Then you will go to second row. This second row and first column. 7 4 11 plus 25. Okay, that is 36. Okay. 7 plus 4 11, 25. 25, yeah, 36. Fair enough. Now you have to get second row second column element here. 8 plus 4 12 plus 5 17. Okay, 8 plus 4 12, right? There is no doubt in it. Yes, there is no doubt in it. 8 plus 4 12, 12 plus 5 17. Okay, now we got a into p plus c, that is left hand side. Now we have to proceed with right hand side, right? Yes, let's proceed with right hand side. What is there on the right hand side? RHS is right hand side. AB plus AC. So now you need to get AB. How to get AB? A into, okay, here we won't write. We'll write it somewhere else. Yeah, here I will write A into B equal to what? You need to write A and you need to write B as usual. So let's get A here. Okay. Okay, that is A. What about B? This is B. Okay. This into this. See, similar, right? 2 by 3. This is 3 by 2. Multiplication is similar. What you will get finally? You have to get a 2 by 2 matrix only. That's pretty straightforward. First row, first column. Here you will get first row, first column element. So 6 minus 12 means minus 6. This is minus 6. This is second first row, second column element. This one 2 minus 6. That is minus 4. Fair enough. Right, right. What about the second row first element, first column element? 3 minus 4 means minus 1 plus 20, that is 19. Okay. What about the second row second column element? 1 0 plus 10, that is 11. So AB we got right. Now we have to get AC, right? We have to get AC. A we know, C we have to copy, right? So similarly, this is AC. This is A, right? Yeah, this is A. Let's use that one A directly. What about C? This is C. The sizes are similar, 2 by 3 and 3 by 2. Now you will get a 2 by 2 matrix only. Okay, fine, fair enough. Let's do the multiplication part for the first row first column element. 8 minus 3, that is 5. Yes, 8 minus 3 is 5. What about the first row second column element? 14 plus 3 17. Minus into minus will be plus, so that is 17. Second row first column element 4 8 12, 12 plus 5 17. So this is also 17. What about the second row second column element? 7 plus 4 11 minus 1, sorry, minus 5 6. So this is AC. Now you add AB plus AC. Next step is adding AB plus AC. AB plus AC equal to, right. So AB, you know, just copy this. Equal to is not required, right? You're right. What is required? Plus is required. Okay, we'll do that. Right. Okay. Now result will be this only, right? We'll come first. You add this minus 1, 13, 36. Yes, 17. Same result you got. Right, you got the same result. So therefore we can write LHS equal to, here we can write, right? Hence proved LHS equal to RHS. Therefore LHS equal to RHS. Okay. Hence proved, that also you can write. Okay, fair enough. Not a very difficult problem. Okay, it seems. Okay. I verified this one. Check the associative property of matrix. This you can do on your own. This also you have to do it on your own. I just gave one example. A minus b into c equal to ac minus b. That also you have to do. Satisfy commutative property ab equal to ba. That you need to verify. Okay. So this is exercise. Name is not given. Okay. Anyway, reducing a matrix into triangular and row echelon form. For the starting lesson it would be very lengthy. If we proceed from this, if we cover this also, so let's postpone this to next session. Okay, thank you, nandri, vanakkam. See how beautiful this nature is. You also start planting the trees. Let us bring a new change in our society. Let us plant the trees and let others plant the trees. Let's take this pledge seriously from now. Thank you.